going to get rolling here. This is number 8 of our Webinar Wednesdays series for Z-Band Technologies this year. We have finished off every month with a webinar on either a generic industry topic or on a specific Z-Band product. Most of the time we do try and keep those two related. And since our July presentation was RF oriented, specifically with RF systems and how we want to design those things, what we're going to get into today is what we call our Signum product, our Signum One product, which is a head-end controller. We are accepting orders for this product now. We're anticipating shipping in Q1 of 2024. We had really hoped to be out before then, but we're still getting a little bit of a kick from component availability, supply chain stuff that's filtering its way through the world. Post 2020, I'm honestly really tired of talking about that and hope that I don't have to next year. But we were hoping to have this out in Q4 or even in Q3 this year, but just the component availability is not gonna let it happen. To start with, and I think this is really the most important thing from my perspective, is why did we get here, right? We, as Z-Band, we have IPTV. We are offering the Insight platform for our ZTV RF system that allows you to get data feedback and monitoring and measurement from your traditional Z-Band RF systems. What we really ended up with in terms of the reason for developing this product is we're trying to solve an internal problem. And it's not necessary. It's not like the fault of our clients or customers or integrators or anything like that. It's just the number of people and the number of companies that deal with and specialize with RF television systems are limited and getting smaller, or consolidating if they're not getting smaller, right? And you see that throughout the industry. And so really what it's left us with is we have this environment where a customer calls us and says, hey, my television on floor 7 isn't working. And maybe it's one TV, maybe it's a whole row of TVs across the entire floor. Maybe it's a small bank of like 4 ports or whatever. And because who we're dealing with is like a biomed engineer or IT or facilities, in those jobs, you can't possibly have all of the tools to test everything that you would need to test all the time. It's ridiculous to think that any entity out there is going to have all of the testing equipment that they're going to need for every system that they have. So you're going to rely on your vendors. You're going to rely on your partners. And so they'll call us, and that's fine. We love getting those phone. Well, nobody loves getting trouble phone calls, but we're happy to help our customers when they have problems. The problem is we can't get any valuable feedback from them, right? Because it's an IT director, or not an IT director, but an IT personnel or a biomed engineer or something like that, that doesn't necessarily have a full understanding of the TV systems and doesn't have any sort of RF measuring equipment, doesn't have any meters, anything like that. We can't get any feedback from them. So yes, we agree that the TVs aren't working, but without any data to begin the troubleshooting process, we're all kind of stuck in the mud. And this has been an issue for Z-Band systems. This is an issue for coax systems. It's really an issue for anybody that's got television. Is if you don't have that meter, you're at this point where you're basically twisting knobs on an amplifier or something like that, and like just hoping that you manage to get everything correct. So what we've done in an attempt to fix this problem, and it's a problem for service providers that have to roll trucks to help clients. It's a problem for integrators. It's a problem for end users. There are a wide number of people that have this problem, and I really felt validated is the wrong word, but that's the word I'm going to use. I finally felt understood, I think, at Infocom this year when we were we had this product on display and we were having this conversation with people. And so many of the clients that we were talking to about this exact problem were repeating stories back to us that are exactly what it is that we're trying to solve here. And so the solution that we came up with is to put in a modular device that basically monitors all of your incoming signal levels, and you can put them throughout your infrastructure. If you have like an MDU or a large coax infrastructure or even a Z-band infrastructure, the system is designed so that the Signum product can function as the master unit for an entire coax-based Z-band infrastructure or coax backbone Z-band infrastructure. This product is designed to monitor and manage all of those incoming signal levels, look for channel overlaps, so try and do drop detection, those types of things. And once you set up your head end, it's designed to maintain that head end. So if your feed coming in from Cox Communications is coming in at 18 dB, and that's what it's hitting the Signum product at, and that's what you want it to be at. You want it to come in at 18, you want it to go out at 25. Well, we'll set that fixed output level so that it goes out at 25. And then if that incoming feed changes from 18 to 15 or 18 to 12 or 18 to 25, internally, our system's going to recognize that and say, oh, I don't want to make those adjustments because I want a constant 25 dB output. That's what I was set up for. And so it's going to do that equalization, amplification, attenuation, whatever needs to be done internally in order to make sure that we're balancing those changes that happens to TV systems on the fly. And that's really, for me, where the infrastructure management portion of this comes in. Because yes, this day and age, there's less variance in the head end side of things, right? Because now we're getting a Ucrypt or a Blonder Tongue Next Gen or a COM 3000 or a Smart Box. You're normally getting some sort of, or like a Well AV Centaur gateway. Any of those devices, I'm trying not to leave out manufacturers that we work with. I don't want to make anybody mad. So really what we end up doing is you get a nice flat kind of consistent output out of a lot of these newer devices. And then where you have variation is when you have amplifiers that are failing in like legacy systems where you don't have a head end and you're just pulling coax off the street from Comcast, Spectrum, whoever you happen to have as your service provider, or in OTA systems. You can get a reasonable variety of signal strength and signal qualities from OTA systems because you're pulling over the air content. So there's a little bit of weather dependencies. There's just some stuff that you have in OTA platforms where you are getting some variation in your incoming signal level, and the Signum product attempts to account for that. And so what you can see here in the design is it's really made to have a variety of different inputs, and the system's modular. So by default, our expectation as Z-Band is that you're going to have one coax input board and one coax output board. That is the belief that we had when we were putting together the system. Beyond that, everything is modular. You can have additional coax input boards if you have a variety of different sources. If I go back to the previous slide, what we kind of expected when we put everything together is you're going to have some internal channels like a local encoder, then maybe you'll have some OTA channels, and then you've got your traditional TV provider. So we're expecting, and really from what we see in the field, most of our clients have 3 to 4 unique sources and service providers. You've got your internally generated content, you've got your cable content. Those are kind of the two that we see all the time. And then we're starting to see more and more interest as the cord cutter mentality that we have at home makes its way into the commercial space of people who are just doing OTA for local antennas and that kind of stuff. So our anticipation is that most of these devices are going to go out the door with either one coax board or potentially a second coax output board. And we made the coax output design modular as well, so that it'll fit the infrastructure that we're working in. So the standard coax output board is designed to output a flat 20 dB MV signal. It is designed to work with the Z-band system, right? It's going to give you the flat 20 dB that we want to see for your traditional Z-band RF infrastructures. We also have a high output board and a variable output boards that allow you to go all the way up to, I think it's between 40 and 45 dB on the output, and control the slope of that output as well. So you can then do your launch design for a coax system. And we have our first project, our first award PO that should be coming in this week for this product, where we're working with a healthcare facility, and they did a home run design on the backbone. So the signal comes into the IDF, and then there's a fiber backbone to get out to each TR. And then within each TR, we located a Signum, and the Signum also will have a modular board for fiber input as well. So you won't just have to do coax input. So we're going to have a single mode fiber input to each of those devices, and then a high output coax board so that we can feed a number of, they're anywhere from 20 to 30 dB taps, depending on how far the run length is. But we actually did a backbone design for a coax system with this Signum product where they are the infrastructure management platform for each TR. Each TR is going to have its own unique device. Each TR is going to have the ability for you to log into the web UI of this thing and make adjustments. But for that project, some of the data runs, some of the cabling runs were 250, 260, 270 feet. And once I account for splitting and everything else, 20 dB just isn't enough. So we do have that high output board with slope control so that when you're designing a coax system and you've got to get to 20, 30, 40 drops of coax on a single floor, you can control the slope, you can control the quality, the amplitude of the output, from these high output coax boards. So it's a really modular system. And then as you can see into the bullets there, it's also DOCSIS 3.1 compatible, so we can handle reverse path if this is like a large multi-dwelling unit or apartment building. You can use Signums to monitor the backbone infrastructure of your cable TV distribution system for that MDU. So this device solves a lot of problems for us as Z-Band in terms of giving our engineers the ability to get some feedback as to what is going on within systems that clients absolutely weren't able to give us before. Again, through no fault of their own. We understand that RF television and TV systems is kind of it's not a niche industry because there's TV everywhere, but in terms of the people who are actually day in and day out supporting it, unless you are making the televisions or you're the service provider, the industry in between those two that's actually focused on the distribution and management of those signals in enterprise infrastructures is actually pretty niche. And so we as Z-Band, knowing that we live in that niche environment, have kind of tried to develop a tool here that we think is going to help our customers. We think it can help MSOs. We think it can help integrators. We really think that this is a device that's going to help our clients and then our partners be able to support their clients in a much more efficient manner, because we're going to be able to get some feedback into these RF systems and into these these coaxial cabling systems when that was never really possible before. So with that as kind of the stated objective is what we're doing here, I'm going to bring over the web UI for this device. So this is the web interface this is our development Signum box. And so what you can see here is when you come in, you're going to get an overview, right? Then you can see here, there's a color-coded legend, port 1. This is the signals that we have coming in. This is the RF channel, the EIA frequency along the bottom here. And you can see each individual port has its own color. And then we have the amplitudes that are coming in versus the amplitudes that are going out after we've equalized everything and set it to that 20 dB flat. You also see that as we're getting changes in power level, we're getting alerts so that you are seeing that kind of stuff. The big one here, and I want to point it out, we're also, not only are we checking for power level changes and we're making sure that we keep a nice fixed power level on everything, we're also checking for channel overlaps. So if in the modern environment, and we covered this in one of the earlier webinar Wednesdays this year, but in the modern environment, there are actually two different channel numbers or channel allocations that we have to deal with when we're talking about TV systems. There's the actual EIA frequency that the content is riding on, and then there's the VCN, or the virtual channel number, that's being presented to the TV. What the patient sees and what we see as the end users, we see the VCN. We see the virtual channel number, 2, 3, 4, or like 17.1, 17.2, 17.3. But what happens sometimes in these television systems is that VCN, the actual channel that's displayed on the monitor, doesn't align with the carrier frequency where the RF content is actually on the cable. So we've had situations before. We actually just ran into one at a customer site down in the Southwest where we configure our encoder for the local channels, we set everything up, and we push it out to broadcast, and we got nothing. We're dead in the water. And that's because the TV channels were presented as 2, 3, 4, 5, 6, 7, but they were actually up on much higher EIA carriers than that. And with this device, you would see that power overlap immediately. As soon as you plugged in the encode 8 for the local channels, oh, we have an RF frequency overlap. Obviously, there's a difference here between what we're seeing from the virtual carrier versus the actual RF carrier where the content's being transmitted. So it will also check for that as well, looking for any sort of RF overlap across your multiple inputs. So in addition to that's a really nice check to have in addition to your power levels. So this is the your immediate input board as far as what you're going to get. I'm going to hide this real quick. And then you're able to go in and do your input setup, right? So you have the ability in a very granular level to go in and adjust attenuation, adjust amplification on all of your inputs. If you know that one of your inputs is coming in just so much hotter than the rest of them, or if you're not happy with where the automated process ended up, and you're like, okay, well, I'm at 25 dB and I really want to be at 23.5, so I'm going to knock that down a little bit or knock that down a little bit. You can do that, and you can go in and make adjustments to the signal after the algorithm has run. On the output setup, you have the ability to take a look at that output level, board input, and then with some of the additional cards, you'll have slope control as well. So you just be able to go in and say, okay, I want to output at 27 dB, and you'll save those settings, and the system will make the adjustment to go out and launch at 27 dB out of that output card. And for those of you who've never really worked with coax systems or never balanced coax systems before, this isn't exciting, right? I'm pushing buttons on a screen and making them go up and down. For those of you who have worked with coax systems and worked with RF amplifiers specifically before, you know that the alternative to this, the alternative to what we're doing here, is turning a knob on a broadband distribution amplifier and kind of hoping that you're adjusting your slope and your amplitude correctly, or that you have the RF meter to actually put on the output of that amplifier and know that you're doing those adjustments correctly. But the methodology outside of the Signum product for making adjustments to amplifiers is very analog, for lack of a better way of putting it. It is, you are turning knobs on devices to control slope and control amplitude without any real visibility into the specific details of the adjustments that you're making, unless you happen to have an RF meter with you, which again, most of our clients don't, and most of our integrator partners don't. Otherwise, we wouldn't be having this conversation. So this part is just it's a big improvement on how you make these controls and how you make these changes, versus the kind of analog world or manual labor world that we live in now. And the great part about this too, from a Z-band standpoint, and not even from a Z-band standpoint, but from our partners' standpoint who also support TV systems, whether you support coax systems, whether you support Z-band systems, doesn't matter, is now you're also giving the availability. I'm going to go back to the overview page to talk about this. For someone who doesn't know anything about their TV system, to give you valuable feedback and give you useful information, right? All I need to know at this point in time is a web address to be able to log into this device. And if I can do that, then I can provide valuable feedback and valuable troubleshooting information or I can have valuable feedback and valuable troubleshooting information provided to me by the client, even if the client doesn't even understand the information that's being presented to them on the screen. So again, the whole idea was ease of troubleshooting, ease of support, and the hope that either as Z-band or as a partner of Z-band and for your clients, you don't have to roll a truck to get feedback from the television system now. That was what we were going for with this, is to be able to get feedback from your RF TV system in a easy to use manner, much easier to use manner than what we've traditionally had to work with. So that's kind of what we came to. Again, the main board has all kinds of attenuation and adjustments that can be made. The pilot tone, as I said earlier, this is also designed to work within a Z-band infrastructure. So if you have a TV signal coming in, we have a client down in Washington, D.C., that their TV signal comes in, and then they feed an existing Z-band Generation 3 distribution unit with the 24 front panel ports and 8 outbound ports. They only use 6 of the outbound coax ports to cascade the system. And we have a bunch of customers who have their system set up like that. Now, rather than use a device that's not designed to be used that way in the head end, you can put in a Signum, you can save yourself some money, and you're using a device for your coax backbone that's actually designed to be used that way. And then obviously the other thing that we wanted to do here is we do have SMTP and email notifications. So if you do get alerts for channel overlap, if a signal drops, if any of that kind of stuff that is a trigger happens, you can get that test email and email notification as well. So if you're doing some sort of like managed services where you want to know before your client if there are problems, this device also has that covered as well. And then we talked about it a little bit at the beginning, and with the pilot tone conversation and with this conversation as well. This is also only phase one of what should be a couple of other new products that come down the line for Z-Band. Basically, the intent here over the next 12 to 18 months is to roll out a system for coax that's really similar to what we do on the RF side of things with the full Z-Band platform, where not only are we going to be able to have some feedback from the TR and from the head end, but we think we're going to be able to put out a device that gets you some edge feedback too, and some automatic signal adjustment of a coax system at the end device, not just in the closet. So there are more iterations coming down the line here that are going to follow on from this product. And I mean, we're really excited because we think this opens up the world of coax to us a little bit, which is still a really big player in the market, in the video distribution market. And honestly, we think this is going to be super valuable for our clients and for our engineering team in being able to troubleshoot problems so much more quickly than what we do now, because we're going to be able to get this feedback, and we're going to be able to get this feedback through a web UI. So I hope it's coming through in my presentation. I'm excited about this. I think it's I won't say a game changer, that's too much. I think it's a little bit of a shift for Z-Band because it allows us to lean into where we're really experts and get into supporting some clients and some customers that we haven't necessarily had a solution for in previous product sets. So I'm excited for it, and I'm going to kind of stop talking and vamping here. And if you guys have questions, you can put it in the Q&A or the chat. I will monitor both of them, and hopefully we can something to work on together with the new Signum product. But yeah, as Z-Band, we're really excited, and I'll wait a minute or two for the questions to come in. Thank you. Price. Oh, that's a great question. Hang on, Jeremy, let me look at your. So there's a little bit of variation in the price. I think Joe Dalto is your territory manager. I will have him get to you with what we think the MSRP is going to be on the base unit. I'm not scared of that number. I just don't want to speak out of turn. I know Joe has some priority dealers and VARs set up in the Southwest, so I'd hate to give you the wrong number. But I mean, we're looking at, just for everybody else that's on the call, we are looking at the MSRP on this thing is probably going to be somewhere in the like $3,500 range. We'll have that defined for sure when we are, finalize the CM here, which is going to happen next week. But yeah, that's I think where we're going to land with it. Robert, yes, that's an excellent question. Yes, you could absolutely do that. So with this device, I'll go to the PowerPoint presentation because it'll probably show it a little bit easier. If you had a local TV channel or local installation, you would want to plug into your port 1 of your coax input board or port 2 of your coax input board. And that's exactly what it's going to do. We're going to take that incoming signal level from those local TV channels, that local TV antenna, and it's going to try and balance to the best of its ability that those incoming signal levels. I will kind of say here with OTA signals, over the air signals specifically, depending on your antenna and some other things, they can be a wide variety. So it's possible we would need to split here and clean up some different signals. Just depending on how the OTA signals were set up, but that's exactly what you would do. OTA comes in, feeds in here, and then out to main distribution, and then the Z-band system or the Signum platform is going to monitor that signal, look for signal level drops, look for any changes. And if you decided to put in some local channels on top of those OTA channels, it would check for channel overlaps there as well. That is exactly the idea. Problem. And then yeah, with that being said, I think that's all the questions that have popped in. If you have any additional questions or anything that comes to mind, please feel free to reach out to your territory manager, reach out to me directly. And we're really looking forward to going this out there in the field. We think it's going to save a lot of time and energy for ourselves and our partners. Um, yeah, hopefully we'll be rolling these out soon, and we will definitely be letting everybody know when they are in stock and ready to ship. All right. Thanks, everybody. Y'all have a wonderful day and enjoy the rest of your week before the long weekend. Take care. Bye bye. Yeah, Jeremy. Yeah, we can shoot you out a copy of the presentation. I will take care of that right as soon as we get off here. All right. Got it. All right. I'm really leaving this time. Thanks, everybody. Bye bye.